All right, welcome back to the channel. Today we're going to finish making this roller. So this is designed to crimp flexible superconducting foil called a niobium titanium foil into the right shape to make into our flex cables. So hopefully you've watched the last video. If not, you can see the link here where we got it basically working but have some issues. So in this video, what I want to do is adjust this top roller so that it presses down on the foil more. So what I did was I bought these spring plungers. I'm going to tap some holes in the top, and then these spring plungers will hold that top roller down, and we'll see how that works. So first thing to do, take it apart and machine and tap these two holes in top. All right, so one side off. This side might be a little harder. Oh, that came off pretty easily. All right, great. Okay, we've got the two pieces. Now we just got to put in a hole from the top here and then tap it. All right, it's time to tap this hole. I like to do the tapping by hand instead of with the CNC because it's less chance of breaking off a tap. Tapping can be pretty tricky to get dialed in on the CNC. It's a little easier on these bigger holes, but for just two holes, it's pretty easy. So what I'm gonna do is use this tap guide to make sure we get started in the right direction, and then this should just go, pretty easy. This is a chip clearing tap, so it should drive the chips ahead of it and make a nice clean hole. I want to make sure I go all the way through so we can be sure that we're going to have a nice fit for our spring plunger. All right. So before we do it, let's clean out these chips and see if the spring plunger actually fits. All right, a little deburring. Here is the spring plunger. All right, I think that's gonna work. All right, we've got the spring plunger in. Next stop, do the other one and then reassemble. Okay, now we just have to reassemble and see how the spring plungers work. Okay, now we put in the spring plungers. Now what these should do is hold, if you see this roller can move up and down, and not easily, but it can. So hopefully this, these spring plungers are gonna go and ride on the shaft and hold it down. Let's see how it works. We should be able to adjust the pressure by changing how deep these are. All right, one's in, it's touching. Okay, now currently we are, we're rolling easily, and we can up the pressure here pretty easily. All right. Oh, that looks, oh, that's really smooth. That's nice. All right. Let's put on the handle and let's see if this works. There's a limit to, these are the strongest spring plungers I could get that would fit inside this form factor. If we need more downward pressure, well, we can figure that out later. But right now, you can see here that we are really nicely rolling with nothing in there. All right, so first attempt, we'll just try to feed through a piece of this copper foil test stock. I don't think I've got it perfectly. Oh yeah, no, this is working real well. Let's see. I have to be careful to, I have a feed table to make sure it goes in square. For now, we'll just see what happens. Yeah, so we were off, our angle was off, but look at that. It was so, it was so hard that it actually split the copper into, at those joints. Just work hardened it. Not exactly what I was aiming for, but an impressive demonstration of putting these grooves in here. So this is clearly working. Now what we gotta do is try some of these harder foils. Copper's much softer than the niobium titanium foil we want to use, and then probably adjust the pressure here to get it right. Now the niobium titanium foil is super hard to get. We're lucky we've got a stock laid in. It's basically impossible to buy at the moment unless you pay an outrageous amount of money. I think the rolling process is very difficult, and after we went through with the manufacturers, they decided not to do it for anybody else. But let's try some stainless steel foil first and see how the stainless works. Okay, so here we have a sheet of 3/16 stainless steel foil. This is 2/1000th of an inch thick, and this is much closer to the consistency of the niobium titanium foil. So let's give this a test. We got it in there a little crooked again. That's going to be the biggest challenge, is we're going to have to feed the foil in. I've got a table that I'll machine to make sure that we can line it up so that we go in square. But just looking at this, looks really good. And I have to put on my cheaters to really get in there. But it looks exactly like what we want. Like that's kind of bang on, I think. I don't think we want it deeper than that, actually. I'll have to measure it carefully, but this looks basically like exactly what we want. So now we'll try some niobium tie foil. Now this is going to be scrap foil for now. Some that came out of the rolling mill at the beginning and the end of the run that was kind of messed up, but it should give us a starting point. All right, here we have a piece of niobium titanium foil. This feels a little thinner, maybe closer to one mil than 2, maybe 1.5. I can measure it. It's got some imperfections, but you can hear it sounds real different. So let's see how this works. One of the things I'm worried about is that this material came out of the rolling mill quite work hardened, so you don't have that much room to put more changes into it without it breaking. So here we go. All right, So here we have the piece. It has the crimps in it. It didn't break. It curled up significantly. This happened too when we were doing it with the music wire mold. I think this is mostly because you're changing the shape and you're putting stresses in with these crimps, and that makes it work. But the crimps, we can just basically hold it flat while we with the mold while we do the welding. But overall, those crimps look great. So I'm kind of surprised, but this is already working better than our music wire version. So honestly, I think we're there. We got it to work. All right, so the next step is gets complicated. So the next step is we basically have to build a system that holds 2 copies of this perfectly still with a wire running through it, and then we're gonna laser weld between each of the wires to make a cable. I have no idea how we're gonna do the laser welding. I'm gonna talk to some people. My guess is we're gonna use some kind of pulsed laser, maybe like a 405 nanometer diode laser, something that'll give us some good absorption in the metal. We probably don't need that much power because it's so thin, but it's going to be fun. I've never done much with laser welding, but we're going to build a rig that is going to immerse the whole thing in argon and do the laser weld. At least that's the plan. We'll see how practical and expensive it turns out to be. Thanks for joining, and we'll see you next time.